Howdy. I built another small project, and I figured I'd try and explain how it works. There were a few complications with it, but it works for the most part. So, anyway, here we go. So the main component in this project is really this remote here. This is an infrared controller, and this little black piece is the infrared receiver. And so basically how it works is each button has a specific code that it will send over through infrared light for this receiver to pick up, and with the receiver, then in the code, you can basically interpret what each button is and encode it to do specific things. And so for this project specifically, we're focusing on the fan here. And so with the fan, you're going to use this remote to change what the fan does throughout the project. We can change the speed of the fan, the direction of the fan. We can give it power, turn it on and off. And anyway, so let's look at some of the other components now. So over on this side of the circuit board, we have this LED bulb here. And what the LED bulb is going to do is the brightness of the LED bulb is going to correspond to the speed of the fan in this project. So we can tell how fast it's going, if it's on or off. So if it's off, the light will be off. If it's completely on to max speed, it will be at maximum brightness. And the way we do that actually is with this pin here connected to the greenish wire. It actually pulses electricity, and the more quickly it pulses it, the brighter it appears. And so we can kind of give the illusion of it being at a certain amount of brightness, whereas we're just actually pulsing the charge going through there. And the less frequently we pulse it, the less bright it'll be, the dimmer the bulb will be. And so that's how that part works. And then similarly, we talked about with the remote that the IR receiver will receive the infrared transmission or from the controller, and then that will actually be received, and we can tell what the frequency of the remote is by reading it through this pin here, the white one. And with that, we can map each button to a specific frequency and change what the fan does. And over on this side, we have the fan. And this thing right here, it's called the L293DH bridge, I believe. But it's a chip that basically allows you to change the direction of the current that passes through it. And so with that, we can actually change the direction that this fan will spin. So it can go either counterclockwise or clockwise, depending on which direction we allow the current to go through. And that's actually changed by these two pins here. So we can change the charge to go through one of them and the other one to be off, and that'll allow the current to go in one direction, or we can flip it and make it go the other direction. Also, the frequency at which we pulse this, just like we were doing with the LED bulb over here, can change the speed of the fan. And so that's the process there. And this was actually the most complex part of this project, because the thing with this fan is there's a specific name for it. Let me see if I can find it. So this fan is actually it's called a brushed DC motor, the component that turns the fan. And it has internal metal brushes which basically constantly connect and disconnect with this spinning thing inside, the magnet inside. And that switching creates what's called micro sparks, and they actually emit a barrage of radio frequency electromagnetic interference. I'm definitely reading this off something, as you can tell, but that actually interferes with the other wires and will affect the reading from this remote that's received by the IR receiver, which was pretty confusing for a moment, because I didn't even know that was happening. but I'll show you in a moment what I mean. So I basically had to make it as far away as possible from the IR transmitter, and on top of that, give it a separate power source. So that's why it's connected to a battery here. And that basically disconnected them enough to where it was not affecting the IR receiver, and it can work for the most part, with some exceptions. But ideally, you want these spaced out as far as possible with separate power sources. And there were capacitors included right at the base of this motor and at the base of this IR receiver, and that basically minimizes the problems here. That's just disconnected. Anyway, let's go ahead and look at some of the code. So in the code here, we have our different components included, and we can define them. All the pins, different pins. This is the LED pin, which maps to the LED. This is the pin that receives the transmission from the IR receiver. And these are the two pins that change the direction of the motor. And so we'll kind of pass over some of this stuff. But this is actually what we use. We take this result that's taken from the IR receiver, and we use it to determine what the button that is being pressed on the controller actually is. And so each of these are the codes received by the receiver when the button for each button, or the code for each button, is transmitted by infrared radiation. And so with that, based upon what we're receiving, we can actually return a certain value and map it manually to which button is being pressed. So for instance, for the case of the hexadecimal FF6897, that's actually what's being sent out through infrared light by the controller, and that is the button 0, and so on. So we have button 0 through 9. We have the channel change button, which is actually, I think on the controller, it says mode. I have the light off, but I'll show you in a moment. And then we also have a power button. And then of course, if none of these are actually pressed and we somehow get a different reading, then we'll return an unknown key. And so here in the setup, we set up all our pins and everything. So we have the LED pin set up, the two motor pins set up, and we enable the infrared receiver to take in readings. And so from there, we can actually go to our loop, which is then going to be continuously waiting for a reading from the IR receiver. And let's go ahead and look at some of that. So first we have a few conditional statements to make sure that we're not pressing the same button over and over again too quickly, or that the readings have a bit of a lag, so that we don't accidentally press the button and then it reads it like 5 times, because this is running at thousands of times per second. So it's this is just in place for safety of that. And then also here, we actually have where we're decoding the value given by this result from the IR receiver. And so we can actually get the key, which is what we were doing here. The method is called decode key value, and that's what we were doing up here, where we were decoding the key value. And so it will return one of these strings or series of letters or numbers, and we can determine what to do from there. And so for instance, if it's something that we don't know, or if it's something that we do know, then we do not want it to do anything unless it's not an unknown key. So basically we're checking to see if the key is not unknown key, and then we will continue from there. The first conditional here is we're checking to see if it is one of the digit buttons from the controller. So we basically check to see if it's a digit, and then we can actually set the fan level based upon what that number was. So basically we have digits 0 through 9, and that will set the fan level of an intensity or how fast it's moving. So 9 will be the fastest it's moving, and 0 will be not moving at all. The other thing here is if we have the power button hit, then we want to turn the system on or off. So it basically inverts this variable. It's called a Boolean variable, which is either true or false. It will invert that and either say if it's true, then it becomes false. If the system was already off, if it was false, then it will become true. And then we can reset some of our values there. And finally, if we hit the channel key or the mode key, what I set it to do is it's actually going to change directions. So it will switch from turning clockwise and go counterclockwise, or it will switch from counterclockwise to clockwise. And so with those variables, we can actually change what goes on when the system turns on. So if the system is turned on, then we can go through all of this. So based on the fan level, based upon the button that was pushed with the number that corresponds to the fan level, we set a target speed. And so this will basically tell us how quickly we want to pulse the charge going through, and that will change the fan speed. And so with that, we can actually, so one thing to note for the fan here is we don't want it to start out not moving at all and then all of a sudden immediately trying to spin it as fast as possible. We want to gradually build up the speed to minimize the risk of damaging our component of the motor. So what we actually do is gradually we're going to increase the fan speed up 1, 1, 1, 1, all until it gets to this target speed. And so we check if it's less than the target speed or greater than the target speed, and we will either increase it, which is what this plus plus is here, or we will decrease it, which is what this minus minus is here. And then based upon the fan direction, it will either set one of the wires to be the fan speed and the other one to be 0, or the other wire to be the fan speed and the other one to be 0. And so that's how we can determine how to change the speed for this fan. The other thing is, if we're changing directions, we also don't want to risk going from immediately, or from going to a certain speed in one direction to immediately going the same speed in the other direction, but rather we're going to gradually shift all the way to no speed and then go on to rotating in the opposite direction. So that's what we're basically doing here. We check to see if it has reached a speed of 0, because we want to decrease it to 0 first, and we keep decreasing it until it gets there. And then from there, we can basically go back up to this where we want it to reach this target speed, but now in the other direction. So it'll stop trying to decrease the speed, and then it will start increasing the speed again in that opposite direction. And then finally, the last thing here is if we're trying to turn if the thing is off, then we want it to slowly decrease the speed and not just immediately drop to no speed at all, so we can prevent it from being broken. And so that's what we do here. Basically the same process as if we were changing directions. We wait until the current fan speed gets to 0 and keep decreasing it, and we just change the direction, and that's pretty much it. So let's go ahead and take a look at how this actually works. Okay, so we have it all set up. It's all ready. I just need to press the button to turn it on. And over here, it will actually show which button we're pressing, and we're going to see the interference from the fan as well. So I'll be sure to show you that. But anyway, let's get this started. So, try and show you all of it. I'm going to press the power button, and I set it to default at speed 3. So it won't be going too fast, but it will be going fast enough to where it's actually moving. And you'll also see this LED bulb turn on while I do that. So let's do that. Very nice. And then we can, well, actually let's check here first. So we see that we pressed the key power, and we see the hex code that corresponds to that. And now let's try increasing the speed to 4. So I got a little faster, if you could hear it. And we can see the press key is 4. Let's try 6. Nice. Press key is 6. Keep going up. 7, 8, and 9. So this is the maximum speed. And we can see the LED bulb is at its maximum brightness. The fan is at maximum speed. And here on the serial monitor, we see all the buttons we press. 4, 6, 7, 8, 9. And so you're actually not seeing the interference from the electromagnetic waves from the motor, which is kind of surprising, to be honest, because it was happening earlier. Oops, battery disconnected. We'll just pretend that didn't happen. So obviously you kind of want to have the battery to be more secure, but this is only temporary, so I was trying not to do anything permanent with it. But as I was saying, you weren't seeing any interference. Don't mind all of this. That is the interference. But basically, the human body can actually act as a bit of an antenna when you touch the motor. And so the electromagnetic field that's disturbing the wires is actually amplified when you press or when you touch the motor itself. And so you actually see some of this random serial noise from touching it, which is pretty interesting. So you get random hex codes that it does not know what to do with, which was a problem when I was trying to build this, because it was basically reading it and disturbing the signal sent by the controller. And so it would not register, it wouldn't do anything. So that was pretty annoying. But changing the distance away from it, as well as the power source, having 2 separate power sources, that definitely fixed the issue quite a bit. And so it works quite well now. So let's try a few other things with this. Let's change the speed to 5. So it decreases a little bit. You can see the press key is 5. And let's change the direction now. So this is the mode button I was talking about. If we hit the mode button, it will now stop and start moving in the opposite direction at the same speed that it left off at, 5. And so we can actually see that here. It had some serial noise, but this is the key we pressed, 5, and then CH is the channel key for the mode, and it changed the direction that this now spins in. So let's just turn this off for a second. Power turned off. And I think that's pretty much it that I have to show you. But when you turn it back on, it'll actually reset to the original direction, as long as it isn't hitting the table. And it will reset at the default speed of 3. So 3 out of 9, which is the fastest it can go. So that is pretty much the whole project. I hope you enjoyed it, and this was kind of fun to build. Definitely spent a lot of time trying to figure out the issue with the interference from the motor, but I learned a lot. So hope you enjoyed it, and as always, God bless.